The way people handle dependency on smart contracts is very primitive, and there is something that we can learn from Web 2.
We want to bring the best of Web 2 versioning to Web 3.
The ERC-7936 is not like the traditional proxy, which forces the use of the latest version.
And we want to enable selected version delegate calls.
The problem that today, when you depend on a contract and the contract is upgraded, all clients are forced to update to depend on the new behavior.
This proposal will maintain a registry of implementations.
And we want to improve backward compatibility and upgrade flexibility.
So the users can choose to upgrade, or they can also choose to stick with a verified version.
This proposal completely solves the problem of breaking updates.
Welcome back to PEEPanEIP, a podcast where we talk about Ethereum improvement proposal and Ethereum standards. This is episode 158, brought to you by ECH Institute, and I'm your host Pooja Randan. Today, we are going to talk about an ERC. It is a standard track proposal which envisions two versioned proxy contract interface. This proposal is documented in April 2025 and currently is in the review status. We are joined by co-authors of the proposal, Raphina, Monica, and Martin. Welcome you all to PEEPanEIP.
Thank you.
Thank you.
Thank you.
Well, I know Martin. Martin is a professor at KTH Royal Institute of Technology at Sweden. I connected with him back in 2022 when he reached out to me for a project which was based on client diversity to increase resilience. At ECH, I remember we also did a survey which was based on client diversity, and it was published in the same year. So definitely there were exchange of conversation, and that was the time when people were preparing for merge. So I believe Martin and his team ended up helping testing the merge with some or the other area. After 3 years, hearing back from Martin was exciting for me because I know they stick around. They wanted to make more contribution to the ecosystem, and thus we see this proposal. And I would love to hear more about you and the team, a little bit of background, what motivated and how you entered into the Ethereum ecosystem, and what brings you to the proposal documentation.
Yeah, we've done a lot in 3 years. We've done more client diversity. We had a grant from the academic call to do advanced client diversity. That's a project we'd be very happy to talk in the good outlet, either web or podcast. But yeah, so we had a very good project on client diversity, another one, verifiable client diversity, funded by Ethereum Foundation. Together with Raphina and Monica, we had also another project funded in the ecosystem development part on software, on dependency analysis. So really this ERC is one of the outcome, a very concrete outcome of an ecosystem development grant, where we make sense of how people reuse code on chain. There is a massive amount of reuse on chain, which is good for the ecosystem, but people don't know how it's done. And so we worked extensively on doing on-chain analysis with academic papers, on writing this ERC to improve the maturity of the ecosystem, and also on building automated security tooling for smart contracts. And this is part of an effort to commercialize our academic results in a product which should be useful for the community, so that this is a maybe.xyz product that we are working on. We also work extensively with bachelor students and master students, so we send them to Ethereum conferences. So we also have a grant for that, and so we send our best students to conferences. So they were, for instance, one bachelor student and one master and one PhD student at Dev Connect in Argentina. And they were all super inspired by the field. So yeah, to sum up, we have a number of different activities, some very oriented towards community, building community, bringing new students, some very heavy duty research where, we publish scientific papers to push the state of the art of Web3. And also we have a commercial arm where we send 3 security solutions to the ecosystem. That's what we are trying to do to cover, basically.
So there is a complete package to build a robust ecosystem. Heavy duty research, specific papers, and selective participants joining different events backed by commercial project. Thank you so much for contribution in the Ethereum ecosystem.
Thank you.
Well, Raphina, if you would like to go next.
Yeah, sure. So I've been working with Martin for 2 years, and I started doing research, like the blockchain-related research, from contributing to open source Ethereum-related projects. And also then I do software supply chain security research, and then I move to the smart contract research. I kind of feel like all these fields are connected. Like, for example, all the software dependency analysis I have researched is actually also very important for our Web3 ecosystem, because that's where, like, the front end is where the users interacted with the contract or like the blockchain. So I feel like after collecting all this, I got to know more about Ethereum, and I know more about the community. So I also like how people contribute to the whole ecosystem by contributing to like doing all the security research, or like have very good place to discuss freely of all the ideas. So that's also why I want to contribute by writing this ERC with Monica and Martin. So yeah.
That's awesome. Thank you so much
Thank you
for your contribution, and because we understand that we can help each other by making a standard so newcomers can just adopt those standards, come up with amazing projects. Thank you.
Yeah, very happy to contribute.
All right, we can go with Monica next.
Sure. So yeah, I'm Monica. I've been working with Raphina and Martin for almost 2 years too. I actually started my research on blockchain on the infrastructure part, so the node, the consensus protocols, and then I was reading a lot of news on blockchain attacks, and I realized a lot of the attacks were happening on the smart contract side, and I was thinking, how can I actually prevent that or make something a nice contribution to the ecosystem that has a bigger impact on the final users? Because at the end of the day, if you're using some smart contract protocol, if it gets attacked, you also lose that money that you invested there, right? I started working with Martin and Raphina on this Web3 software supply chain challenges that we could improve and contribute to the ecosystem so it can mature. And we take a lot of
This is amazing. I'm thankful for your contribution on the application side of Ethereum by building this standard. But since you have interest in nodes and other things on the Ethereum protocol side as well, perhaps you can take a look at other interface or networking standards, and maybe one day we can have some suggestions coming up from your end as well. I really appreciate you all working in the ecosystem and helping new contributors in. And I look forward to hear more about this proposal. So without further ado, let's peep in.
It's a pleasure to talk about this work and to disseminate this work. So Raphina, Monica, and myself have been working for quite some time on the problem of dependencies on chain. So how people reuse existing contracts or depend on other contracts. And after many months of work and doing on-chain analysis, lots of on-chain analysis, we realized that the way people handle dependency on smart contracts is very primitive, and there is something that we can learn from Web 2. And this ERC is a result of this work, where we bring a fundamental concept of Web 2, which is a concept of version dependencies, to on-chain and smart contracts. So the next slide gives a bit of background. So it's, we all know that in blockchain everything is immutable. Yes, it is. So when it's Apple forever. Yet in Ethereum we have a fundamental way to handle mutability. It's through proxies and upgrades. And this is essential for doing proper software engineering because this is how we can fix bugs. This is how we can add features. And this is something which has been pretty much researched by the community. So there is, the early EIP 1967 on proxy storage slots to avoid storage collision. The well-known universal upgradable level proxy standards, and a very sophisticated standard on diamonds, which to do a lot of the very advanced use cases. Yet all those EIPs suffer from the same problem, is that, if I depend on a contract and this contract is upgraded, then I will directly depend on all new problems. So we will suffer on new bugs, and we also suffer from security problem. If a malicious actor is able to upgrade a contract, they would be able to impact all clients of that contract. So it's a major problem, and there has been real-world exploits about that. So that's the problem which we solve with this EIP. So we solve the problem that today, when you depend on a contract and the contract is upgraded, all clients are forced to update to depend on the new behavior. It's a real problem. When you have a software company, usually you want to support like gradual rollout. You want your clients to depend on V2 when they're ready to depend on V2. You don't want to force all your clients on the same day to depend on V2. So that's a problem we are solving with ERC. Same thing today, more or less, when you depend on a contract to be upgraded, you fully trust the proxy admin, the proxy owner, that they will not get their keys compromised. But as we all know, all keys end up being compromised. So our ERC reduce the trust assumption on the proxy admin. So we solve the security risk of having malicious new implementations, malicious upgrades. And also from a pure software engineering perspective, we also solve the problem of breaking changes. If it turns out that a new good update is breaking for me, well, I could still perhaps depend on the previous version. So that's the problem we are solving with this ERC.
So basically, Martin said that there are problems with the current proxy pattern, and the ERC-7936 is not like the traditional proxy, which forces the use of the latest version. This proposal will maintain a registry of implementations, so the users can choose to upgrade, or they can also choose to stick with a verified version. So basically, we maintain a registry of the implementation versions, and we map the version identifier to the implementation address. And then the caller can specify which version they want to call. So if we see the picture here, let's say the cat is a user, and through the proxy, they can dedicate a call to the food they want, like the implementation contract, which is dry cat food. But one day the owner want to change it to the wet cat food. So basically the dry cat food is not an option for the cat anymore. But with our ERC, although there are new options of the wet cat food, the cat can still choose the dry cat food because he choose to and he's happy about it. So let's say an example, which is the admin push a new implementation, and it contains a bug. So basically, all the users using the proxy fallback are routed to the buggy implementations. They would lost funds. But with this ERC, because the old version is still there and they are still default and registered, so the users or the integrations can keep calling the old audited version while the function execute that version at the old version. So the result is that only the callers who explicitly choose to call the new version are affected, and most of the user remains safe. So the core function of this ERC is register version. For this one, you can add new versions, and you can also set default version, which is a fallback version, and also execute at the version is basically you call a specific version. Also, you can get implementation and get versions. And Monica, do you want to continue?
Yeah, sure. So Raphina introduced basically the core of our interface, our North Star, the goal that we want to achieve with this ERC. So this is the interface that we propose in our formal PR. So it formalizes what are the core functions that Raphina already told us about. And now we wanted to talk about a bit how we get to this goal. So a bit of the implementation. So first of all, we have to identify the biggest challenge here because we are sharing a bunch of implementations and we're allowing the user to choose it. But at the end of the day, all of these implementations share the same state, which is the proxy, right? So the question here, the hard question here is actually how can we prevent buggy implementations from leaving the shared state in an inconsistent condition for other implementations? Any buggy implementation could be just a bug introduced by a developer, for example, or even a malicious actor introducing some backdoor to the new implementation, right? So this could potentially lead to a very inconsistent state that other implementations, while being benign, could run on a very bad state and could suffer from it. So the approach that we decided on is actually to scope each contract function to a well-defined storage region. So we can have this storage isolation to limit the impact of the bugs. So we can ensure that the state corruption is contained and does not compromise the unrelated logic. So we can thereby maintain the partial system functionality even if we have failure scenarios. So for example, we can scope that the function F1 is working and only modifies the storage slot 1. So even if a malicious implementation tries to make any change to other storage, we can restrict that and invalidate that transaction. So the F2 code can keep working even if we have already accepted some malicious implementations or buggy implementations because the storage slot is different. So we create a frameworks for anyone who wants to try to implement this concept to follow. And what we suggest currently is to, for each external function of your contract, try to identify which variables can be modified and the ones that must remain unchanged. So for each function that you allow any user to call in your proxy and your implementation, you try to define the invariants of each function. And then you try to have a snapshot of these immutable variables, so the ones that they should not touch during the execution of this function. So having this snapshot, we want it in memory. This is crucial because when you are delegate calling between contracts, you actually share the storage, but you don't share the memory. So the malicious implementation or the buggy implementation does not have access to the memory in your proxy, for example. So after this, you allow the delegate call to execute. And once it finished, you will get a new snapshot of the variables that you defined in step 1. At the end of this, you want to compare these two snapshots. If they match, great. It means that this scoping remains the same. But if they don't match, you want to revert this transaction because it might lead to some inconsistent state that you don't want. So this is the overall framework that we recommend anyone who tries to implement this ERC to follow. And of course, this framework comes with a trade-off. By following this ERC, we're telling developers and users to actually put more computation on each contract. We will have to create a snapshot and we have to compare these snapshots. So this will have to consume more gas for each call to our implementation. So for our future work, we actually want to explore and evaluate different implementations of our proposed framework. And later on, we want to conduct gas consumption benchmarks. And finally, we want to identify and implement gas efficiency optimization. So at the end of this review process, we want to have a report so everyone who wants to adopt this ERC has an informed decision whether they want to adopt it or not. What are the trade-offs? What are the good things and the bad things that the community can be aware of? So this concludes our presentation and our introduction of our ERC. We want to bring the best of Web 2 versioning to Web 3, and we want to enable selected, versioned delegate calls, and we want to improve backward compatibility and upgrade flexibility. Thanks so much for giving us this opportunity to talk more and discuss about the ERC.
Thank you so much for this presentation. It is really an interesting proposal. I know this EIP talks about a lot of things. It talks about addressing multiple problems, providing flexible selections options to users, and also enhance backward compatibility. We would be talking about the improvement that it might bring to future users. I have a handful of questions, and I would like to get into it one by one in order to understand this even better. In the beginning of the conversation, you mentioned about different proposal, UUPS upgradability standard, which is already existing, proxy storage, and diamond standard. Just trying to understand from the point of view of this proposal, you don't find them anywhere in the required sections. You are just trying to address the problem that were identified in these of standards and help provide a solution. Is that a correct understanding?
So it is not a requirement. So if you don't use any of those ERCs, you can still adopt this one. And if you're also already using that ERC, you can still try to adopt our ERC. So it can be compatible with them according to each developer's needs, but it is not a hard requirement. If you don't have that type of upgradability, it doesn't mean that you cannot use this new type of upgradability.
That makes a lot of sense. We talked about post-adoption, like when there is any upgrade and everybody is forced to implement. Obviously, this proposal provides us that flexibility whether we want to go ahead with that or not. With buggy updates, you mentioned about state correction stored in storage slot. But I'm a little curious to understand here, how would one know that this is a buggy implementation? If we know, obviously we would not choose that, but without implementation, how someone will get to know that we should not go for the new updated one, we should continue going ahead with the previous one?
So here it's a very known problem in Web 2 as well, that you depend on let's say React 3.5 and then somebody says you should use the latest version. And what is done in Web 2 is that you should wait a little bit. You should wait for some other users to use the new version before switching yourself. And if you are super careful, a big enterprise, you might wait a bit longer to have really guarantees that it's working reasonably well. And so here it's a bit the same. So, early adopters, Gen users might directly go to the new versions, but more careful users might wait for having, a couple of days, a couple of blocks, a couple of transactions. And they would decide how much, how many days, how many transactions you want to activate. But if they, if they wait for 1,000 other users to do transactions to migrate to the new version and everything is fine, then they wouldn't migrate. What's for sure is that the developers themselves of the new implementation, everybody makes mistake and they might push a buggy implementation. This happens regularly.
Right. So not only you just have to be a smart contract developer, you also have to be a smart implementer. Wait for some time, make sure it is all good, and then go ahead and implement that. I guess it was in the presentation, someone comes up with more implementation of these proposals. I wish someone one day comes up with this kind of implementation where there is a test scenario available before it goes into implementation. So this proposal provides option, which is very good. It helps with some kind of protection against bad updates. For security consideration, are there anything new or any trade-off that any team or project may have to do if they want to adopt this standard?
So this is a very good point, and what Monica has presented was really to the point. So this proposal completely solves the problem of breaking updates, but it solves partially the security aspects depending on what you are able to protect. So this was the last slide of the presentation, that if you are able to completely specify the state which must be protected for a given implementation, then this proposal gives you security guarantee. If we, many smart contracts, they might use, lots of mappings where we don't really know which part of the memory will be impacted. And then it might become harder to protect, again, a very malicious user who knows exactly what they want to change and the part of the state they like to corrupt. So it doesn't completely solve the fundamental problem of delegate calls. Delegate calls is something, it's known in the industry that this is something very powerful but also very dangerous, and it's much better than the previous proxy patterns, the previous ERCs. But yeah, there are some very advanced attacks that can still go through.
Yeah, we like to think that this proposal is narrowing down the attack surface of delegate calls, but it comes with a trade-off with all of these invariant checks that we're doing. We do consume more gas. That's why we want to work in multiple different implementations to properly benchmark what are the gas consumptions so we can publish this to the public and they can make an informed decision on whether they want to have a secure contract, a more secure contract, or whether they want to risk it and use less gas.
So I take it is still under the wish list that we need to come up with benchmarking about gas consumption and gas efficiency. It is not there yet. Is that a correct understanding?
Yes, for different implementations. We have a couple of naive implementations, but of course the scope of each smart contract currently is so big, and we can only start with ERC-20, for example, some contracts that are popular, and start benchmarking those. But there are so many diverse smart contracts at the moment that we want to be thorough and include all of this diversity in our benchmark too.
All right. From my experience of looking into ERCs that comes into the process of standardization, I'm just sharing this. I may be completely wrong and editors may find it very different, but in the security consideration section, I do not see any mention of this benchmarking. As you mentioned that every contract may have different implementation, different parameters, and you cannot go for benchmarking for all. But from my perspective, it would be a good idea to give them a hint of like, this is something that people should consider, would be nice addition. But my worry is if you mention that, then the editor might want to have the benchmarking done before they move the proposal to the finalized status. So it's a call for authors. How do you guys want to proceed in this proposal? But I feel it is a good piece of information that every implementer might use before choosing to implement this EIP in the project. Well, moving ahead, you did mention that there are small implementation, and maybe for those small implementation, you could have the benchmarking done. So I'm curious, is there a proof of concept or reference implementation already ready that people can refer to? Maybe we can add the link in Fellowship of Ethereum Magician or somewhere.
So yes, we have a proof of concept implementation, well tested, which is in our repo. We are happy to share the link, and we are happy to take contributions, external contributions on this proof of concept implementation.
Yeah, I think that would be helpful because this is one of the requirements that has been added recently, though it has not been formalized yet. But we want that if a proposal is in the repository to become a standard, there has to be some implementation. So even if it is reference implementation or POC ready, it's a good idea to share. Let's see if it is a viable proposal, it is a viable standard.
Fully agree. We love proof of concepts and reference implementations.
Yeah, very well. Looking ahead, how do you see this standard influencing enterprise adoption of Ethereum smart contract? I'm asking this because I understand this provides a lot of flexibility, and all the standards that you mentioned in the beginning of this conversation are very well received by the community.
So I would say this ERC is very enterprise. Versioning is very enterprise. This ERC is very enterprise. So to some extent, this ERC really contributes to making on-chain development more mature with sound software engineering principles. And we actually expect the first users and implementers to be more on the enterprise side, mature, established Web3 protocols. We expect them to be the first users more than the gens going for new fancy contracts directly. The core of this ERC is an enterprise mindset of stability and security.
Yeah, and also like large-scale adoption or enterprise adoption, they care about the compliance or like the security part. Actually, this ERC can provide more transparent and more aggregated information for all the enterprise who want to do the compliance. And for example, they can easily build like a dashboard for like which version we are using, or like what is this GitHub source code can be reproduced from the contract itself. So we would say that it's very helpful for all the like enterprise adoptions.
I mean, I can definitely see some operational benefits of this proposal, which will help bigger projects to keep working uninterrupted in case of any maybe malicious upgrade or bad upgrade or by mistake upgrade. It can still continue working in that direction. I'm assuming that you are not aware of any project already implementing this proposal. That's perfectly all right, but this is also very much recommended to all ERC authors that get in touch with people to get this proposal implemented. I really loved your idea that you would want it to be adopted by enterprise rather than getting into a simple project, because that would like have more visibility of this proposal. We would love that, but we would encourage authors to like talk more about it. We'll come up with different platforms where we can share about this proposal, and perhaps that would help you. Well, I see this proposal is in early stage of standardization. It is still in the review status. How comfortable are you guys with the specs? How long would you want it to wait before we can move it to next step, which is called last call, and eventually to the final status?
I think we are not far away from going to last call. So we are polishing the last security aspects. We will add the link to the reference implementation. We waited for some bit to get feedback on Ethereum magicians. So yeah, we are confident. The component is good. We received lots of very good feedback from the community when we talk about that. It's really novel. It really contributes to something new, which is important. So yeah, we are now polishing the last parts before going to last call and then final status.
That is very good to know. And please feel free to reach out to editors in office hour in case of any help and support needed to move this proposal forward. Well, thank you so much. This was really interesting. So I think we are coming towards the end of this conversation. Any message, any call to action that you would like to share with the community?
I think one call to action would be, if anyone has suggestions, if anyone has an idea of an implementation, just send us an email or send us a message and we'll review it. We love software diversity. We want to have as many different implementations as possible because this is what makes software reliable too.
And this is the world of open source. So we would love to have any kind of contribution. Thank you so much for the message. Perhaps people can reach out to you on Fellowship of Ethereum Magician and leave a comment with their ideas or thoughts, and they can be connected.
Thank you very much. We are very happy to be here today. Thank you very much for hosting us.
Thank you, everyone, for joining us on PEEPanEIP. We hope to see this proposal moving forward to last call and eventually to the final status. All the very best from our side. Please reach out to us for any support during the transition of these statuses. We do organize EIP editing office hour that is there on Tuesdays at 1600 UTC. We would be more than happy to help you around. Dear listeners, thank you for tuning in. If you liked the episode, please share with like-minded people. Check out our description section to get more information and related resources. How do you like PEEPanEIP series? Let us know via comment below, or you can also email it to us at team@eatcatherders.com. We would love to hear from you. And if you have got any suggestions around which EIP we should bring it to the podcast again, we would love to hear any kind of feedback from your end. This is the last episode for year 2025. So happy holidays, and we will see you around in 2026. Cheers, everyone.